topic for today is circular motion, which is one of the type of motion we did before. Now, when we are talking about circular motion, what are the things you need to know? So you need to know about definitions of sometimes example of circular motion, how to derive V is equal to omega R, where omega means angular velocity, where V means linear velocity or speed. Then centripetal acceleration is equal to V squared over R. Then we have centripetal force, which is same thing as centrifugal force, which is equal to mv squared over R. Now let's start from the definition. There, when you have to define circular motion can be defined as movement of an object along a circumference of a circle. I said circular motion is the movement of an object along circumference of a circle. You can see, or you can still define it as movement of an object about the axis of an object, of another object. For instance, look at this one. This is an object. This object is moving like this. It's moving about the axis of another object or space. But if this object itself is moving like this, that is what? Rotational motion. Then, what are the examples of circular motion? Look at the way this planet circling the world, the moon, the sun. Then the moon, the way the moon circling the earth is an example of circular motion. Now look at this object. When you are winding an object like this, so the object is moving in circular motion. As it's moving like this, we have two velocities. There's linear velocity in it, then we have angular velocity. But the first thing is, linear velocity will silent, not see it, but by the time the rope cut, the object will move tangential to the circle. The linear velocity will now take place. Then the angular velocity is what you are saying. Then we have two forces acting on it. And the one of it is called centripetal force. The one that is acting toward the center of the circle. That is one in my hand. While the second one is called centrifugal force. Now we said we have centripetal and centrifugal forces. Now, centripetal is one acting toward the center of the circle. Then if there is no equal and opposite force, the body will not continue in circular motion. Therefore, the force acting toward the center of the circle, that keeping an object moving a circular path is called centripetal force. While the one that is equal to that force, but in opposite direction, that will keep that object moving in circular path is called centrifugal force. Now, let's go and try to derive this formula. That is V is equal to omega R. Then let's start by comparing the two velocities together. We have linear motion, we have angular motion. Now, in case of linear, we normally have distance. That is the distance that an object covers. But in case of angular, when an object is moving in a circular path, we don't measure the speed of that object with the distance. We normally measure it with what? Angle, which is theta. And theta is equal to 2 pi r. Now, look at the time. Time taken by a linear object or object moving in linear motion is t. It's that same t we have for circular object. Then let's come back to the speed or velocity of an object moving linearly. We are going to say distance or displacement over time. Then in case of angular, it's almost the same thing. This one, distance, but distance in case of circle will be 2 pi r or theta. Therefore, the angular velocity, which is omega, is equal to theta over time. Now, how can we now derive this formula from what we have got here? So, let's start from an object moving in circular path. Now see, let's say the object is from this point, and it moves from this point to this point. It has covered a distance x. Now let's join it. This is the center of the circle. We have this line, we have this line. By the time you reduce this angle such that this line is perpendicular to this, then we have this one as hypotenuse, opposite. This one we serve as what? Hypotenuse. We have r. Therefore, sin theta from the diagram will give you opposite, which is distance over x over hypotenuse, that is r. Then let me tell you, when the angle is very small, for it's very small theta, like I told you, when this one will be what? Perpendicular, the sine of angle will give you the same value as what? Theta. Therefore, theta is equal to x over r. When you cross multiply,
or just leave it like this. Now, let's go back to this place. We have our omega is equal to theta over what? Over t. Then make the theta the subject of formula. I mean from here. We started from here. Let's make the theta the subject of formula from here. So we have theta is equal to omega t. Then we said theta is equal to x over r here. Then replace this theta with omega t. In that case, we are going to have omega t is equal to, we replace this theta with omega t. We are going to have omega t is equal to s over r. Is equal to s, which is distance, over what? Over r. Then let's divide both sides by t. We are going to have omega is equal to x over rt. So therefore, omega is equal to 1 over r multiplied by x over t. Now let's go back to our table. Now what is x over t? Is equal to what? Velocity or speed. Therefore, our omega is equal to 1 over r multiplied by v. Therefore, we have omega is equal to v over r. So this one implies that v is equal to omega r. That is how to derive this equation. Let me tell you, we still have another method. We have another method of deriving that formula. Now let's start from this one. Very simple. This one is straightforward. We have from this way, we have v is equal to x over t. Then our x in case of circular is 2 pi r. Then let's replace x with 2 pi r. Therefore, we are going to have v is equal to 2 pi r over t. And don't forget, under simple harmonic motion, our f is equal to 1 over t. So this formula becomes v multiplied by 1 over t multiplied by r. Therefore, v is equal to 2 pi f r. Then under simple harmonic motion, omega is equal to 2 pi f. Then replace 2 pi f with omega. We are going to have v is equal to omega r. These are the second method. These are the two ways of deriving the formula. You can derive it like this. You can use the first method. Now let's go to centripetal acceleration. Centripetal acceleration. From simple harmonic motion, our centripetal acceleration A is equal to omega squared r. Omega squared r. Then let's replace our omega. Don't forget from here, make omega the subject of formula. We are going to have omega is equal to v over r. So from this equation, we have omega is equal to v over r. From here, make omega the subject of formula. When you have this one, put it here. Therefore, centripetal acceleration is equal to v squared over r squared multiplied by r. This r cancels one of these r. Therefore, our centripetal acceleration is equal to v squared over r. So that is how to get centripetal acceleration. Then, finally, centripetal force and centrifugal force, which both of them, don't forget, both of them are equal, but they have opposite direction. To derive them, since we have force, is equal to mass times acceleration. Therefore, centripetal force will give us this mass multiplied by centripetal acceleration. You change your linear acceleration to centripetal acceleration to give you v squared over r. Therefore, v centripetal force is equal to mv squared over r. So this is how to derive centripetal force. So when you are given a question, you will be asked to calculate centripetal force or centrifugal force. It's this same formula you are going to apply and you get your correct answer. So inshallah, when we get to simple harmonic motion, you get a formula for how to derive omega, how to get this 2 pi f for the formula for omega, then how to get 1 over t for f. So that's the end of the